Hello friends, welcome to Input Output Campus. So today in this video we'll discuss about the most commonly used algorithm, which is binary search algorithm. This searching algorithm is mostly used for searching elements in an array. The main benefits of binary search algorithm is it does not scan each element in the list. It performs the searching to the half of the list. So the binary search takes less time to search an element as compared to a linear search. So this is the main benefit of binary search. So we can apply this searching algorithm to check if the target element is present in an array or not. Okay, so here some input is given. Here is an array A and here is a target element. So we have to check if this target element is present inside this array A or not. So we can do this by applying different search algorithm, but today we will solve it using binary search algorithm. Okay, our first task is to calculate the size of the array. So the size of the array is suppose n. If n is the size of the array, then its upper index will be n minus 1 because the array starts from index 0. So its lower index is 0 and its upper index is in minus 1. Okay, so lower index is 0 and its upper index is in minus 1. Now we'll find the middle index. So what is the middle index of this array? So to find the middle index, we will average these two, that is lower plus upper divided by 2. And this will give us the middle index of this array. Okay, so here you can see n is the size of the array. So the size of the array is 1 2 3 4 5 6 7. So here n equals to 7 and lower index is 0 and upper index is n minus 1. So n minus 1, that means 7 minus 1 equals to 6. So this is the upper index. Now the middle value is equals to 0 plus 6 divided by 2, which is equals to 3. So 3 is the middle index. So 0, 1, 2, 3. So here will be the middle index 3. Now to perform the binary search, we'll check 3 conditions. We'll check only 3 conditions. Okay, so case 1, case 2 and case 3. So there will be only 3 cases. So first we'll check if the target element is in the middle of this array or not. So the middle element is 7. So how we will get this element? We'll write the array and the index, the middle index. The middle index is m. Okay. If target is equals to a of m, that is 10 is equals to array of 3. So array of 3 equals to 7 and here our target element is 10. So if 10 is equals to 7, no, 10 is not equals to 7. So this is the case 1. Okay, first we'll check the middle element. If this is the target element or not. If this is the target element, then we'll return the index. Case 2, if the target element is less than the array of m or not. If this condition not satisfied, then we'll check this case 2. If the target is less than array of m, if the target element is less than the array of m, then we'll search this portion, only this portion. And if the target element is greater than this middle element, then we'll search the target element into this portion, that is the right side of this middle element. So that will be case 3. If the target is greater than array of m, then we will search the target element right side of this middle element. So we know the lower value and the upper value, that is the lower index and the upper index of this array, and we know the middle index. So if the case 2 satisfied, then we will decrease the upper value. Our upper value was here, that is n minus 1. Now our upper value will be m minus 1. Why? Because we will search only this portion. So this is our middle element and its index is m. So our upper value will be m minus 1. and our lower value will be 0. So for this case too, lower value will be 0 and upper value will be m minus 1. So what will be for the case 3 if the target element is greater than array of m? So for these cases, we will search only this portion and our middle element was 7. Okay, so middle element was 7 and we will increase the lower value. Why? Our lower index was 0, so our lower value will be updated. So what will be the lower value? So lower value will be m plus 1 and our upper value will be n minus 1. So there will be no change in the upper value. Okay, hope you understand the question and the concept how to solve it. Okay, we can solve it differently, that is using iterative approach or a recursive approach, but here we'll see the iterative approach. So before going to the solution, please try once by your own to write the whole code of this binary search algorithm, and after that was the solution. Okay, so let's write the code. Okay, we'll write the code using C++. Okay, first of all, we'll write the basic format of the C++, that is as include bit/standard C++.h using namespace standard. First of all, write the main function. Okay, and in the main function there will be an array and the element of the arrays are, okay, let's copy it from here and paste it here, and there will be a target. So target element is 10. Now we need the size of the array. So you know how to calculate the size of the array. Int n equals size of a divided by size of int, or you can write here size of array of 0. Okay, now we'll write a function. Suppose the name of the function is binary search, and here we'll pass the array a and the size of the array n and the target element. So now I'll write the same function here before this main function, and the return type will be integer because it will return an integer value. So binary search, int binary search, and inside this there will be an array int n in target. Now what is the lower index of the array? So the lower index of the array is suppose int low and it contains 0. So the lower index of the array is 0 and the upper index is n minus 1. So n was the size of the array and the upper index will be n minus 1. Okay, so now we'll write these three cases. So case 1, case 2 and case 3. And before that we have to calculate the middle index of the array. So int m equals to lower plus high, low plus high divided by 2. Okay, so this will calculate the middle index of the array. Now our case 1 was if the target element is equals to array of m, then we'll simply return the index m. Okay, return m. So this was our case 1. So case 2 was else if target element is less than array of m. So if the target element is less than array of m, we'll update only the upper index. Okay, so if target element is less than array of m, then we'll update the upper index, that is the high index will be updated by what? Updated by m minus 1. Okay, this was our case 2. And our case 3 was if the target element is greater than array of m, then we'll update the lower index value. Okay, else only the lower value will be updated, that is lower value will be m plus 1. So we will not check only for one element for this array, we'll check for all of these elements. So for that we have to write a loop here. So what will be the loop? So the loop will be while loop. While the lower index is less than or equals to higher index. While this lower index is less than or equals to this higher index, we'll do this operation. If the loop finish and any of these condition is not satisfied, then finally we'll return minus 1. Here minus 1 means we don't find the target element into the array. Okay, so just return minus 1 if the target element is not found. Okay, So what will be returned from here, that will be came to this main function, and here we'll store the element into a variable. Suppose the name of the variable is index, so int index. So here we'll check if the returned element is -1 or not. If this is -1, then the target element is not present into the array. If this is anything else except -1, then the target element is present and will return in index. Okay, so let's write here if else condition. If the index is not equals to -1, if the index is not equals to -1, then we'll print element found at then the index. Okay, else we'll print not found. Okay, here our output was yes or no, that is if the target element is present then we'll print yes, otherwise we'll print no. Okay, you can do so, but we can write it like this also to check if this target element is present inside the array or not. Okay, so let's run the code. Okay, here you can see the output is element found at 5, that is element is found at index 5. Okay, our target element was 10 and 10 is found at 0, 1, 2, 3, 4 and 5. Okay, this is the index 5 and 10 is found at this index. Hope you understand this, and this was very simple and easy to understand, and this algorithm is very helpful for searching an element. So hope you like this video, and if you find this video helpful, then please like the video and share it with your friends. And thank you for watching this video. See you in the next video. Till then, take care.